we're going to be working on chapters 13.1 and 13.2. We'll start with a graph of a parabola. So in this example, we have y equals f of x, and we're going to use it to answer the following questions. A. Identify the vertex as an ordered pair, labeling it on the graph. Does it have a minimum or a maximum y value? This point right here is the vertex. It's the, in this case, maximum value of the graph. I'm checking out the scale, and it looks like it is at the x value of -1 and the y value of 9. So that would have a maximum y value. Find f of -3 and f of 1 in function notation. Label them on the graph. Why do you think they have the same value? Okay, f of -3 equals 5, and f of 1 also equals 5. They have the same value, I would say, because they go up to the same height. And this parabola has a bit of symmetry, and that is important. We're going to be talking a little bit about the line of symmetry. There'll be a line that is where you could potentially fold your graph and things would line up nicely on each side. Solve for f of x equaling 0. And that is when your y value or your graph is at 0, or the height of 0. Write the solutions in set notation and label them on the graph. What special points did you identify? When does f of x equal 0? Right here and right here. And those are your x-intercepts. And that is the point 2, 0, and the point -4, 0. So the solutions are the set of -4, 0, and 2, 0. You could label it that way. In set notation, we have a set of points. X was -4 and 2. Either one of those I would accept as correct. And I identified x-intercepts. Identify the vertical or y-intercept as an ordered pair, labeling it on the graph. Okay, I'm going to have to go up here a little bit, right there, and you are the point 0, 8. State the domain and range in interval notation. Now, in this graph, it's implied that it goes on forever and ever in the x direction, to -infinity and infinity. In the y, it goes up to 9 and goes down to infinity. So let's say that. Domain and range in interval notation. Say domain is from -infinity to infinity, and we'll say the range is from 9 to -infinity. Now I should write my smallest number first, so let me flip that around from -infinity to 9. And we don't get to be at infinity, but we can get to that 9, so we'll do inclusive brackets there. Last one, solve for when f of x is larger than 5, writing your answer in interval notation. Okay, so here's that line that I drew earlier at 5. When is it larger than 5? They had us talk about the when up here at B at -3 and 1 were the points where we were at 5, and in between -3 and 1, my graph, a parabola, was above that line. I'm going to write that in interval notation. Between -3 and 1, put my x in the middle. X was bigger than the -3 and less than the 1, but it said interval notation, so that would look like this, between -3 and 1. with the parentheses. The only problem I have with interval notation is that kind of looks like a point from -3 to 1, kind of looks like the point -3, 1. But hey, that's what they asked for, that's what they're getting. And we're going to use the parentheses because it said strictly greater than. This is a quick review of some things that are important when you're graphing a parabola. Parabolas are symmetric, so there's going to be this line of symmetry that goes through a parabola, and parabolas are U-shaped. Sometimes that U-shape is upside down, it can be N-shaped, I suppose. The domain of a parabola or a quadratic function is from -infinity to infinity. You can put really anything in. Now, some parabolas have minimum values, like the one here. That's a low point. And some have maximum values, like the one we just did. And in both cases, the minimum and maximum values are the vertex point. That's the vocabulary word there. And that vertex point helps you determine the range. The range goes from that vertex point up to infinity or down to -infinity, depending, again, which shape we're looking at, whether we're looking at a U or an N here. And if you have intercepts, like an x-intercept or a y-intercept, those can be found by either looking for when the function equals 0 or what happens when you put 0 in for x. When you're graphing your parabola, you'll want to make sure that you include 4 points: your y-intercept, your vertex, and your x-intercepts. Those 4 points really define everything that we'll need to know about the parabola. And then you need to follow other rules of graphing, like giving me a scale and labeling things x and y, and it's always a good idea to label the graph with its name. Remember all of those other rules, but those 4 points are the 4 points that we're looking for. Now, not all parabolas will have x-intercepts, but if they do, you need to label them. You are going to do this yourself. I've given you a g of x equation. You can graph it by using some Desmos technology or just putting in these numbers and getting out your answers. I'm asking you to find the x-intercept, the y-intercept, the vertex, state the domain, and the range. In class, we're going to do one that's similar.